When dealing with K-rated transformers, understanding the sizing requirements for the neutral conductor is crucial. K-rated transformers are designed to handle nonlinear loads, which produce harmonic currents. These harmonic currents, specifically the third harmonic and its multiples, are additive in the neutral conductor in a three-phase system. This can cause the neutral to carry more current than the phase conductors under certain conditions. If the neutral conductor is not properly sized to handle these harmonic currents, it can overheat, leading to insulation failure, damage to equipment, and potentially fire hazards. The National Electrical Code, or NEC, provides guidelines for sizing neutral conductors, particularly in situations where harmonic currents are present. Generally, for a K-rated transformer, an oversized neutral is required to accommodate these harmonic currents. To determine the appropriate size for the neutral conductor, several factors need to be considered, including the transformer's K rating, the percentage of nonlinear loads, and the applicable codes and standards. A common practice is to increase the neutral conductor's ampacity to at least the same ampacity as the phase conductors. However, in some cases, it may be necessary to further increase the neutral conductor size based on the specific harmonic current content. For instance, if the nonlinear loads are significant, such as in data centers or facilities with a high concentration of electronic equipment, the neutral conductor may need to be sized at 175% or even 200% of the phase conductor's ampacity. The NEC provides tables, such as Table 310.15b16, that offer guidance on conductor ampacity based on conductor size and insulation type. These tables can be used as a starting point for determining the appropriate neutral conductor size. However, it is important to perform a thorough analysis of the harmonic currents present in the system to ensure that the selected conductor size is adequate. In many cases, using a larger neutral conductor than required is a safe and prudent approach, especially when there is uncertainty about the exact harmonic current content. When selecting the material for the oversized neutral conductor, copper and aluminum are the most common choices. Copper has a higher conductivity than aluminum, so it can carry more current for a given size. However, aluminum is less expensive and lighter than copper, which can be advantageous in some applications. When using aluminum conductors, it is important to ensure that they are properly terminated and that the connections are made with compatible connectors to prevent corrosion and overheating. For a 100 amp K-rated transformer, the following guidelines can be used for sizing the neutral conductor. For copper conductors, a size of 2 American wire gauge or larger is recommended, as per NEC Table 310.15b16. For aluminum conductors, a size of 1/0 AWG or larger is recommended, also as per NEC Table 310.15b16. These are minimum sizes, and it may be necessary to use larger conductors depending on the specific installation and the harmonic current content. To verify the suitability of the selected neutral conductor size, it is advisable to perform a harmonic analysis of the electrical system. This analysis can be conducted using specialized equipment and software that measures the harmonic current content in the system. The results of the harmonic analysis can be used to determine the actual current flowing in the neutral conductor and to ensure that it is within the conductor's ampacity rating. If the harmonic analysis indicates that the neutral conductor is undersized, it should be replaced with a larger conductor to prevent overheating and potential hazards. In addition to sizing the neutral conductor, it is also important to ensure that the neutral busbar in the electrical panel is adequately sized to handle the increased neutral current. The neutral busbar should have sufficient ampacity to accommodate the maximum neutral current that is expected to flow through it. It is also important to ensure that the neutral busbar is properly insulated and that all connections are tight and secure. When installing the oversized neutral conductor, it is important to follow all applicable codes and standards. The conductor should be properly supported and protected from physical damage. It should also be clearly identified as the neutral conductor using appropriate labeling. The connections to the transformer and the electrical panel should be made with approved connectors and should be taught to the manufacturer's specifications. Safety is paramount when working with electrical systems. Always to energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to work on electrical systems, consult with a licensed electrician. In summary, when working with K-rated transformers, it is essential to understand the requirements for sizing the neutral conductor. An oversized neutral is typically required to accommodate harmonic currents and to prevent overheating and potential hazards. The appropriate size for the neutral conductor depends on the transformer's K rating, a percentage of nonlinear loads, and the applicable codes and standards. Always consult with a qualified electrician to ensure that the electrical installation meets all safety requirements.